This is the sixth and final section of the Trigonometric Identities and Equations chapter, and here we're going to be solving equations but using identities as well to help us simplify things, or maybe things look like quadratics and you need to factorize them. So just a reminder, our identities are sine theta is equivalent to, not sine theta, tan theta. Let's get the right one. Tan theta is equivalent to sine theta over cos theta, and sine squared theta plus cos squared theta is equivalent to 1. And when we're solving these trig equations, look out for quadratics. Yeah, you may have things that look like quadratics. Okay, e.g. you might have something like 2 cos squared theta plus 5 cos theta minus 7 equals 0. Yeah, I'm not saying that's going to solve, but what we might do is say something like let y equal cos theta. So we end up with something like 2y squared plus 5y minus 7 equals 0. We can solve that by using the quadratic equation, and then that will give us a value for y, maybe 2 different values of y, which basically means that cos theta equals that. Yeah, and then from there we'll get our principal solution, and then from there we'd use our Car's diagram. So a bit more going on. Okay, solve for theta in the interval 0 to 360, a popular one. And the first one here, we have 2 cos squared theta minus cos theta minus 1 equals 0. Now, that's a quadratic. What some students do, they'll say let y equal cos theta. So that will give us 2y squared minus y minus 1 equals 0. We'll see if we can factorize that. So we're going to have 2y in the first bracket. So the two numbers at the end, they both need to be 1s, like that. And I'll want to get negative 1. So that means that negative 2 plus 1, yeah, that'll work. So from here, I could basically say I've now got 2 cos theta plus 1, cos theta minus 1. Right, so let's have a look. From the first bracket, I get 2 cos theta plus 1 equals 0, which means that 2 cos theta equals negative 1, which means that cos theta is negative a half. Right, find the first solution. Cos inverse of negative a half. Let's do that. And I get 120 degrees for that one. Okay, now I'm going to use my Car's diagram to find any other solutions. So 120 degrees is over here. So if that's 120 degrees, that means that this gap here is 60 degrees. So these are all 60s, like this. C-A-S-T. My principal solution landed here, where cos is negative. Where else is cos negative? Here. So that other solution is going to be 180 plus 60. So 180 plus 60 is going to be 240. So let's just write down 240 here. And that came from this one. And the 120 was the principal solution here. Right, let's have a look at the second bracket. So we've got cos theta minus 1 equals 0. So that means that cos theta equals 1. And if we do the cos inverse of 1, we get 0. So theta equals 0. Now we should be able to work out this without a cast diagram. In fact, the cast diagram doesn't really help. So the graph of cos, right, so it's 1 at 0 degrees, and it's also going to be 1 at 360. Okay, so there are solutions there. So the final solutions are, got these two and these two here. So theta is 0, 120, 240, and 360. Let's just highlight those. So that's part A. So you notice that what we did was factorize it, look at the two brackets, made them equal to 0, found the principal solutions, and then found any other solutions as well from our cast diagram or the graph. Right, part B, hopefully got enough space here. Part B. Right, so we have sine squared theta minus 30 degrees is a half. So the first thing we do is to square root both sides. So we'll have sine theta minus 30 is equal to, now remember, we have a positive and negative square root. So we've got positive or negative 1 over root 2. So we need to look at each one of those separately. So let's start with the sine theta minus 30 is equal to the positive 1 over root 2. So sine inverse of 1 over root 2, the positive 1. Let's do that. Sine inverse 1 over root 2. We get 45 degrees. Cast diagram, see if there are any other solutions. Like this, 45 degrees is going to be here. Let's draw a crossing. All the 45s here. Our first solution landed in this quadrant here, where everything is positive. So C-A-S-T. Sine is positive there. Where else is it positive? Over here. So that solution is going to be 180 minus 45. So 180 minus 45. So from the sine theta minus 30. So let's write that down. So this will be 135. So this is what theta minus 30 equals. So theta minus 30 can be either 45 degrees or 135 degrees. So if we now add 30 to those, we will get 75 degrees. And if we add 30 to 135, we get 165. Okay, so we've got those so far. Now we're going to look at when sine theta minus 30 is equal to negative 1 over root 2. So we'll do the sine inverse of this negative 1 over root 2. So sine inverse negative 1 over root 2. What does that give us? Sine inverse negative 1 over root 2. And we get negative 45. Right, let's see if there are any other solutions. So negative 45 is going to be down here. C-A-S-T. So there's our first solution there. So these are all going to be gaps of 45. Our first solution landed in the part of the cast diagram which was over here. Sine is negative there. Where else is sine negative? Over here. So that's going to be 180 plus 45. So 180 plus 45, which is 225. So we've got theta minus 30 equals negative 45 and 225. So now we can work out theta by taking away, adding 30. So if we add 30, we get negative 15. And then we get 255. This one's no good. The negative 15 is outside of the range. So we get a third solution here. So putting our three solutions together, the two we've got there and the one we've got there, we can say right at the very end that theta can be 75, 165 or 255. Let's just sign like that as our final solutions for part B. Okay, the first thing to note is that from the copy of the book I had, this is a printing error. So that should not say sine squared. If that's in your book, rub it out. Otherwise, it doesn't solve. Yeah. Now, what I want to do, we can't solve it when it's in, we've got sine and cos all mixed together. We need to have just sine or just cos unless we can factorize it. So we're going to make a substitution, and the substitution we're going to use is this one, sine squared theta plus cos squared theta is 1. And if we rearrange that, then cos squared theta is 1 minus sine squared theta. So that'll be very useful. Right, so 2, and now we'll do the substitution. 1 minus sine squared theta plus 9 sine theta, not sine squared, equals 3 sine squared theta, or x. Expand the brackets, so 2 minus 2 sine squared theta. I don't want to put theta, it should be x. So I used to put in theta. Plus 9 sine x. And then we'll bring across the 3 sine squared here equals 0. So that will give me 2 minus 5 sine squared x plus 9 sine x equals 0. Let's multiply everything by negative 1. So we get 5 sine squared x plus 9 sine x. Minus 9 because we're multiplying everything by negative 1. Minus 2 equals 0. Now, rather than messing around and trying to work out if it's going to factorise, I'm going to use the quadratic equation. If a is 5, b is negative 9, and c is negative 2. So that'll give me minus b, 9, plus or minus square root b squared, negative 9 squared, minus 4 times a times c, all over 2a. So if I do that, this will give me the values of sine x. So when I've got a plus, I get sine x equals 2. When I've got a minus, I get sine x equals negative a fifth. Right, so the first one here, there's no solution to this. Remember, sine x needs to give you, or cos x needs to give you a number between 1 and negative 1. So if you did the sine inverse of 2, it will come up error anyway. But we can find solutions for the next one at the bottom. So we're going to do the sine inverse of negative a fifth. So sine inverse negative a fifth, and we get negative 11.5 to 1 decimal place. So just write that down, sine inverse 1/5 is negative 11.5. We want to see if there are other solutions, so we use our cast diagram. Remembering this time that we're looking for answers in the range from negative 180 to plus 180, CAST, and we've got negative 11.5, that's down here, so that means 11.5 up here, and same up here. Our principal solution landed here. We're solving an equation for sine. Sine is negative down there. Where else is it negative? Here. Okay. Now, keeping an eye on the range that we want to find the solutions on, there isn't much point going this way. Yeah, because the final solution we want is going to be around there. Going around to negative 180, we're looking for solutions that way. Well, we've got the negative 11.5. So x equals negative 11.5. Then the other one is going to be 180, or no, be negative 180 plus 11.5, because we want it as a negative angle, not as a positive angle. So that will be x equals negative 11.5 degrees, and the other one, let's just do negative 180 and plus that answer, and we get negative 168.5, negative 168.5. Right, you should now be able to do exercise 10F on page 221 to 222. So on these types of questions, look out to see whether you can factorize. And it's normally like a quadratic, which may mean you need to use a quadratic equation or something similar to find any solutions. Look out to see if there are any identities. Identities, let's spell it right, that you can use to help you solve it. So it's either going to be sine over cos is tan, or it's going to be sine squared plus cos squared is 1.